Hey everybody, this is Larry. This is day 28 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join the Discord channel, let me know how you feel. Today we're going to go over Reconstruct Itinerary. So if you're an old-time viewer of this channel, I'm actually trying something new where I change the order of things, but I do the explanation first and then you could watch me live solve this problem afterwards. So reading this problem, my first thought is that it is Euclidean path. And why do I think it's Euclidean path? Because, well, you have to use order ticket once and only once. And a ticket is basically an edge connecting between A and P, between point A and B, right? And from that, you have to use all the tickets, and that all the tickets do form a valid itinerary, meaning that there is a Euclidean path. So from that, that's pretty much how you solve the problem. And it's a path because you have to start at JFK, and it could be a cycle if the last element is JFK, but it doesn't matter, right? So that's kind of the idea of how you solve this problem. And there are a couple of algorithms to solve Euclidean paths. I think it's a little bit of a weird problem for an interview because not everyone knows Euclidean path, and also if you're able to, so the algorithm that I use is called it's some guy's algorithm. I'll put a link below to the Wikipedia page. But the point being that the algorithm is named after someone, right? So like, if you didn't already know it, can you come up with it in the scope of an interview? Probably not, but that's okay. Do you even think you need it? I think that it's not super necessary. I think that, yeah, I mean, if you have practice a lot of things and you're comfortable with everything else, then sure. If you don't know it, then maybe just add it to your list. But I think for an interview, one is very unlikely. Two is that even if it comes up, there are just so many things that you're probably not as strong with that you can show up with like binary search or something like that, right? So for that reason, I don't like this problem for an interview. For competitive programming, it's comes up here and there, so enough times that you should probably know it, or at least know to where to Google for it or something like that. But yeah, so the code is a little bit iffy, and again, you'll watch me code it later, but basically I just go through it, and it's almost not worth me explaining my code in the sense that this is just an implementation of the algorithm, and I made some changes so that it uses an adjacency matrix just to make it slightly easier, but it makes the complexity way more complex, or it makes the running time a little bit slower, but for this problem it was good enough. And yeah, that's all I have for this problem. Now you're gonna watch me try to solve it live. Hey everybody, this is 28th day of the Leetcode June Daily Challenge. Let's get started. This is the live stream. Reconstruct Itinerary. Reconstruct Itinerary. Given a list of airline tickets represented by a pair of departure and arrival airports from to reconstruct the itinerary in order. All the tickets belong to a man who departs from JFK. That's me, actually. Thus, the itinerary must begin in JFK. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order when read as a single string. Okay. All airports are represented by 3 capital letters. You may assume that all tickets form at least one valid itinerary. You must use all ticket once and only once. Oh, you have to use all tickets. So this is basically, wow. So this is basically Euclidean path. It's a graph theory construct, and yeah, I mean, I think I'm gonna just get right to it. It's kind of tricky though, mostly because I haven't done it in a while, so I don't actually remember exactly the implementation. But the idea is that you start at JFK. And because that there's at least one valid itinerary, then we know that there's an Euclidean path. And from that, there are a couple of ways to do it. The really tricky way is to kind of construct cycles and then combine them in a way. But I'm going to do it the greedy way of basically you take a path, and this is me try to figure it out from first principles, which is that you take a path, and if taking that path allows you to still have an Euclidean path, then you take that path. Otherwise, you don't take that path yet, right? And what I mean by that is, for example, if you have a case like maybe there's another thing that goes to SFO and then goes to JFK, right? Like maybe it's this input, but there's another path from SFO to JFK. Then you would have to do the JFK last, because otherwise you would not be able to go to Atlanta because there's no other way to go to SFO. But I think that for this problem, because we're guaranteed that there's a path, I think that it maybe is okay. But I would say that also it is not a great interview question. So yeah, because I don't think Euclidean paths should be an interview question thing, but that's besides the point. So now I'm gonna try to prove it again from first principle and from the invariants that I remember about Euclidean paths. So I don't know if the implementation will be quite right the first time, because I'm pretty rusty about it because it doesn't come up that often. But yeah. But let's go through the tickets first, right? So let's have two arrays, and by arrays I mean hash tables, because I'm a little lazy. I like it this way a little bit more. I don't need extra stuff. So now I'm just setting up the in degrees and the out degrees of the tickets. So in degree of 3 plus 1, and then out degree of u plus 1. Yeah, and then let's just convert this to a adjacency list. So now, okay, so now that we have this up, we have to start from JFK. Okay. So one thing to note from this is that we can go through all the keys in edges. No. I think we just have to keep track of all the names that we saw. Is it insert or add? I actually don't know if it gives an error on dupes. It's been a while. Did I spell that wrong? Collections.defaultic. I don't know how I spelled it wrong, but yeah, okay, so it doesn't crash, that's good. And then now for each one, we know that we want to start at JFK, and now we have to figure out where we end up, right? And so the answer is either we will end up in the number that has an odd number out degree, right? Yeah, okay. And the reason why I remember this is that if you know, for every node that you have for Olean path, you have to go outside. You have, you know, if someone comes in and then someone has to go out, right? The only place where that is not going to be the place is wait, is it out degree is equal to I guess in degree is equal to out degree. Maybe that's easier to represent, right? Then that would be your answer, unless that's JFK, because that's where you're starting. Last is equal to name. So as long as we do name last, we should be okay. What an annoying problem. But yeah, but this is just backtracking then. No, I mean, it's not quite backtracking. You just do an edge over time. But yeah, let's just first is equal to JFK. Let's just do last is equal to none. If this is still none, then that means the last place we're going to do is JFK. That means you do a whole circle loop thing. So then now we sort every, yeah, let's sort all the edges, so that we always try to go from the, you know, what's optimal in terms of lexicographically shorter, earlier, that is. Yeah. Oh, you are right. Thanks. Okay. So then now we start at JFK. And we can do it this way, but and because this graph is always good, we just have to make sure that the entire graph is still connected. Because if it's not connected, then we're not good. Okay. I think so, yeah. Let me think about it for a second. I think you're okay. And I think it is just for edge in on, let's say, for next node in edges of node. Can you still oh my god, this is a really annoying problem. That I've done before, but I don't remember. I mean, not, I don't think I've done it on Leetcode. I just have done Olean path before. But we want to, do I want to remove it? So now what is the complexity? So basically, okay, fine. Maybe okay. I think I wanted to remove it in a good way, but actually what I need is a I think we want a deck so that we could remove from the beginning easier. But yeah, okay, fine. Pop left. I don't know if you could sort. You could sort. Okay, let's actually just make this a list by default. We sort and then we just set it to the deck version of it, so that I could do pop left. Okay, sorry, having trouble with this. But yeah, now I can do this because now it actually is a deck. Let me just run this real quick, just to compiling errors or whatever. Okay, so it doesn't complain. That's good. Okay, so now we pop off the next node. We call construct of node, and then at the very end we add node to the list. So enter that. And I think that's mostly it, maybe. It's been a while. I have to, okay. No, I have to do non-local. And I don't think maybe I have to, but I guess I actually don't need this. I thought I might have just in case. Oh no. Oh, that makes sense. Huh. How do I remove this in a good way? Man, my Python is terrible today. And also apparently I don't need my alt degree, but I did it just so that I could do this, but okay. Basically what I don't want is that when it goes back to node, then it still has that thing again, right? So also this is wrong. This should be next node. Whoops. Eh. I guess that's fair. Okay, fine. Let's just keep it in a way, and then we'll do. I mean, this will still be too. I think I'm just trying to figure out how to do the sorting part. I forget if it goes one way or the other on the greedy. So, okay. So let's kind of let's take a look. How did I? Now that would definitely not work. I actually meant to do this. Okay, this should be okay, maybe. But yeah, I guess I did it backwards. Okay. Let's try the second case. Oh no. Oh. Oh, I guess in this case it's just, and there's always one. Oh, How do I do this in a good way? Huh. Usually I don't use an edge list for this. That's the okay. Let's just do it straightforward way with a matrix of sorts. I guess you have to do something like that, otherwise. Set is not sorted, right? Yeah, I mean, I'm just really having trouble with doing it in Python, because usually in probably doing C++ and it'll be okay, but it's just been a lot. I don't think I've actually done this in Python before, so I'm just trying to do this in a good way. Oh yeah. Yeah, this may not give me the right answer, but let's see if it runs first. Because of the sorting reasons. Oh yeah, it don't need to pop anymore. Basically, converted it from what? Oh, whoops. Basically, we converted it from linked list, or sorry, adjacency list to adjacency matrix. Yeah, but so this works, right? In that it gives you the right answer. Oh, sorry, it gives you an answer, but doesn't give you the best answer because it's not sorted, and that's the problem here. But actually, I think we could just do something like. Okay. Don't like the performance of this, so I'm going to just change names as you go to. This is very ugly, by the way, but just trying to figure out working thing first. Yeah, seems okay. Let's try some base cases of just one thing, and then maybe two things. And there could be more cases, but it's a little bit late, so I'm gonna just YOLO it if it works. Oh no. Oh no, that's just me putting in the test case, I think. Maybe. Yep. Okay. Oof. Okay. Let's give it a go. Oh no. I mean, I'm short a whole thing, so that's not great. Okay. give it a go. Did I miss something? I missed going to JFK. How did that happen? And it would go to JFK and is there multiple? No, it only goes there once. How did I just miss the entire flight? Huh. That's odd. Oh no, I mean I do have the JFK, just not in the right order. So what am I missing? Well, I called the tier to JFK to tier to JFK multiple times. There's definitely something off. Yeah. But also it's just doing something weird. Because this shouldn't be true the second time, the tier to TIA to JFK. Because that should not be a path that is possible. Debugging is always the most expensive thing, so I don't know what I want to say, but okay, well, don't print out everything. I hope it's just something silly. Okay. So JFK goes to a new and tier, text tier. I guess I should print that out too. Sad face. Okay, JFK, it sees these, it goes to a new, okay. And it goes to, you see, do. Okay, JFK goes to a new is false, but tier is true. Tier goes to JFK is true. How did JFK now has all these edges? And all of them are false. Dun dun dun. It's because I have to do something like it. And that. Is the answer right now? Nope. Okay. Why? Why do you like go back to tier or TIA? I don't know. I don't know what airport that is. So. The right answer is tier goes to a new. But we already did tier goes to a new. So this is right. Then JFK, then tier. Wait, did I just miss it? So okay. If that is okay. Whew. I thought I was being silly. But this is an easy fix. It's just that the two edges from tier to a new. Okay. So my algorithm is still it's just that I had a wrong assumption somewhere. So now we could just change this in int. Change this to, you know, increment by 1 if it's named there. If it's greater than 0, we decrement. And then okay. All right, all right, all right. That looks way better, right? Okay, all right, all right. So that is the thing, is that when you're unfamiliar with the implementation side, that's why you should always practice implementation, is that you want to do silly things like this. But that said, I'm not so that you should practice all linear paths for interview purposes, but just in general for implementation. Okay. I also did make a incorrect assumption that there's only one path between 2 points. Usually they tell you that, but in this case they don't, and I just didn't realize that. Okay, let's give it a good submit and give it a good fingers crossed and accept it. Yay! Whew. Yeah, so the complexity of this algorithm, it's Euclidean path. Definitely look it up. This is essentially linear-ish time in the number of edges, because as you kind of see, we look at each edge. I mean, the way I implement it with an adjacency matrix, it's a little bit weird, because you should be able to do this with adjacency edge, but in terms of implementation, you cannot remove edges while you're iterating through it. So maybe I could have done that smarter actually. But yeah, but because of that, I did an adjacency matrix, so the complexity is a little bit trickier in terms of time complexity, but it's still roughly linear, because, or maybe linear square, quadratic, depending, because maybe my case degenerates, but it still should be fast enough for small n's. They don't tell you what n is, but that's just the standard Euclidean path, so feel free to read up on Wikipedia and stuff like that. This is relatively straightforward if you had practice. For me, what you see is in this video, and this is why I like to tape these live and not to skip ahead or just be like, oh yeah, this is easy, this is perfect. You should already know Euclidean path. I mean, I'm probably good at it, programming and solving these problems, but I don't remember every single detail for implementation. You saw that I made a couple of mistakes here and there, including just the assumption that there's only one edge. But yeah, these are things that with practice, one is maybe you stop making some of these silly assumptions, but you also just get better with implementation. And yeah, and I hope that by watching me struggle, this is how, like I remember the invariance about this problem where you add an edge and there's an Euclidean path if the graph is still connected, and so forth. Some of this is that they tell you that there's a routed itinerary, so that makes it slightly easier. If not, then you have to check that that's the case, where you count in degrees and out degrees, which actually I didn't end up using. But yeah, otherwise it's quote unquote standard Euclidean path, but it's not something that is I don't know. I don't think it would come, or I don't believe it should be in scope for an interview. Maybe things will change if you, especially if you watch this in the future and things get harder all the time. For competitive programming, it does come up relatively often, but not that often. Just like relatively often, and not on the Leetcode level generally. Though I mean, I say that, but this is a Leetcode problem, so but I honestly don't think I've ever heard anyone ask or get asked an Euclidean path question on interview. I could be wrong. There are a lot of people out there. There are a lot of interviews out there, but that's just my experience. And yeah, that's what I have with this problem. I'm taping this in the wrong order, but you'll yeah, let me know what you think, and I will see you tomorrow. Bye bye. Okay.